So this is 2.4b, solve using square roots today. So we're going to solve a different way. Rather than solving by factoring, we're going to solve using this technique called using square roots. Okay? So the problem's going to look like this. You're going to have a quantity squared within the problem, whereas all the ones that we did last night didn't have that quantity squared, right? Okay, so the first thing you're going to do is isolate that perfect square. All right, so isolate this quantity that's squared, I should say. So first thing we did here is we added the 3 over and we got to 12. And this is where we started the recording. Okay, at this point then, what I'm going to do is get rid of that squared. I'm trying to solve for x still. That's still the goal, so I want to get rid of the squared by taking the square root of both sides. Now here's the trick. I believe you may have learned this strategy last year. And if you did learn this strategy, you learned to put a plus or minus. Did anybody learn that last year? Do you know why you need to put a plus or minus? Okay. Actually, you guys, if you have that square root to begin with, that's what's called the principal square root. The principal square root is always positive. The square root of 25 is 5. If you punch that in your calculator, you're just going to get 5. It's not going to give you plus or minus 5, right? It's not both of those. So this answer has to be positive, and since we don't know what x is, we can't guarantee that when I take the square root of this quantity, I can't guarantee it. So I have to guarantee it, and here's how I do that. This is the step we always left out, but this is the step I want you to see. This is kind of cool because it fits in with what we have been doing. When I take the square root, I have to guarantee that this is positive, and I can guarantee that by putting absolute values around it, right? Now I know that expression is positive. And again, that square root symbol says the answer must be positive, okay? And then this would be root 12, which we're going to simplify that in just a second, okay? Then this is what we just did in 2.3. There's two things that could happen here, right? Inside that absolute value, I could have a positive root 12, or I could have a negative root 12. That's why you put the plus or minus, okay? So that's why then what I would say is x plus 2 is either positive root 12 or negative root 12, and we usually just group those together as plus or minus root 12. So I think last year when you did this, you went from this step to this step. That really is the reason why. A radical, and this is going to help us in a future unit, okay? A radical, what comes out has to be positive. This is guaranteed that it's positive, okay? But then by the definition of this, what's inside could have been either positive or negative, okay? So kind of interesting. All right, let's clean up root 12. Root 12. You can either make the factor tree, or you can think of the biggest perfect square that you know is a factor of 12. What's the biggest perfect square that's a factor of 12? 4, right? This is 4 times 3. So I'd factor it that way, and then the square root of 4 is 2, and the 3 would stay under. Okay? Or if you continue the factor tree, right, you get to that, you pull out the 2, and the 3 would stay under. Okay? However you like thinking about that. Either way, this is going to be plus or minus 2 root 3. And then you're going to subtract the 2 over. And usually we put it in front of the plus or minus. So when you subtract it over, it becomes a negative 2, and it goes in front. And that's your answer. Your answer typically when you do square roots is going to look like that. There's another thing that we used that you probably did last year that gave you an answer with a plus or minus in it. Anybody remember what that was called, where you had that plus or minus? The quadratic formula. Yeah, that we're doing that in the next objective. 2.5 we'll do the quadratic formula, so not today. However, you're going to have a couple problems where you're cleaning up, just simplifying, and we're going to talk through those. That's getting you ready for the quadratic formula. But anyway, so the answers kind of look like that. You would get the same if we had FOILed this all out, multiplied it all out, and then factored it using the quadratic formula. We would have gotten that as our answer. It's kind of quick. It's a cool little strategy. Let's try another one. 2 times the quantity x minus 2 squared equals 10. Okay? The first thing you want to do if you're going to solve this by square roots is get that perfect square thing, that quantity squared, all by itself. Okay? So to do that, I'd need to get rid of the 2. How would I do that? You can't distribute in if this is squared. You can't do that. If this quantity is being raised to any other power, you'd have to do something to the 2 to be able to do that. We'd have to take the square root. I don't want to do that. Instead, divide. Yeah. Divide both sides by 2. This is where I can cancel. Okay? So I'd have x minus 2 quantity squared equals 5. Okay. Once you have that isolated, you're going to take the square root of both sides. I would like for you, for now, to put in this step with the absolute values. Later we're going to skip this step, but for now put it in. Okay. So this right here, because it's going to help us in a later unit a lot if you'll put those absolute values in right now. I have to guarantee that that answer is positive. I'm going to do that by putting absolute values around it. Because it's possible that could be negative if x was smaller than 2, right? Okay, equals root 5. And then it's at this point, because of that absolute value, that you create the two cases. One is where it's positive root 5, the other is where it's negative root 5, right? Okay, so I'm going to set that up, though, all in one step. This is where I'm going to put the plus or minus. Okay, add the 2 over, put it in front. Those are your two solutions. 2 plus root 5, 2 minus root 5 are the two solutions for that. Any questions? I'd like to know on a scale of 1 to 4. 1, I totally have this. 4, I totally don't. Where you're at with this, please. Where are you at with this? Okay, then we're just going to do one more. Number 3, don't know if this is going to work. I'm making it up right now. Let's go. Yeah, let's make it fun. Okay, let's go 3 times the quantity x minus 1 squared. I got to think this through. Minus 4. How about equals? Could have it be 8, but I think that's going to give me 2 real solutions. So let's have it be, I wanted something that when I add 4, I get something divisible by 3. So how about 11? Equals 11. I like that. Okay. So isolate the quantity squared, right? So the first thing you'd do is you'd add 4 to both sides. And so I'd have 3 times the quantity x minus 1 squared equals 15. Okay. And in here again, you know, distributing in is something I see again, that's a common mistake. You can't do that because of the power. All right. That is, you can't just distribute the 3 in. So we're going to instead divide by 3, cancel those away. X minus 1 squared equals 5. Next step, square root, right? To get rid of the square. We're trying to get x all by itself. Okay, now what follows this, you guys? What do I want for right now? What do I want you to put? Absolute value of x minus 1. Okay, again, the square and the square root, they cancel each other, but you have to guarantee the answer is positive. Okay, and so then here, root 5. And then it's at this point where you create the two cases, and that is that x minus 1 could either be positive root 5 or negative root 5. And then the last step is to add the 1 over. Those would be those two solutions. Okay, the last type of problem you're going to have is where they're going to ask you to simplify, and I just want to review this. This is the precursor to the quadratic formula that we're going to do tomorrow. So we'll just do a couple of these. It'll look like this. 2 plus or minus root 20 all over 4. So you did the quadratic formula and then you got to this point. Okay. Anybody know how we could simplify that? Ashley?
It's like a triangle. You can divide by 2 on each of them.
Okay, yeah, as long as you can divide by 2 on everything. Now, you got to be careful. I can't divide under the radical.
Yeah.
So we'd first need to pull anything out. Can we simplify root 20? Okay, let's think about root 20. What's the biggest perfect square that goes into 20? 4, right? It's 4 times 5. Okay, what's the square root of 4? 2. See, that would give you a pair of 2's that would come out. The 5 would have to stay under. 2 root 5. Okay, so I'm going to write this as 2 plus or minus 2 root 5 all over 4. I like what I heard you say, a triangle. I like that. Kind of thinking of it as a triangle. I don't know if your math teachers last year talked about it that way. But as long as I can reduce it out of every single term, you have to be able to reduce it from every single term outside the radical. The same thing, I can do that. And so what goes into all of those? A 2. Now, you're dividing is what you're doing. So when I divide this by 2, what's left? 0 or 1? 1. Okay, so not 0. This is 2 divided by 2. So I'd have a 1 here. I'd have a 1 here, but we don't need to write that because we have root 5. It's understood to be there. And then 4 divided by 2? 2. Did any of you learn to break it up? To break that up, the fraction up that way? Or did you learn it this way last year in math too? Is that new to anybody? Did you guys all do this? Okay. I want to do one more of these, and I'm going to squeeze it in right here. Number 5, let's do this one. Negative 3 plus or minus the square root, big square root, 3 squared minus 4 times 2 times negative 6 all over 2 times 2. Can you see it?
Yep.
There's a quadratic formula. We'll review it tomorrow, but it's there if you remember it. There's a little song that goes with it. I actually know 3 different melodies to that song. We'll sing them all. Square root. Over 2a. And there's Jingle Bells also, and there's Row, Row, Row Your Boat. We'll sing them all tomorrow. All right. Okay, so now be careful here. Careful with your order of operations, right? We would do 3 squared first. This is subtraction, minus, okay? This is multiplication. So 4 times 2 times negative 6, which I'm going to put it in parentheses just because. What's 4 times 2 times negative 6? Negative 48. So what we're going to be doing here is subtracting a negative 48, which would make it plus, right? So it's really 9 plus 48 when you subtract a negative, all over 4. What's 9 plus 48? 57, all over 4. Okay, then what we would be looking at is factors of 57, and I'm not real good with that right off the top of my head. There is something I know for sure goes into 57, because 5 plus 7 equals 12. What should go into 57? 3, right? If when you add the digits, 3 goes into that number, then 3 is going to go into 57. Okay, can you do that division? How many times does 3 go into 57? Can you do that in your head? 3 goes into 5 once. You'd have 2 left. 3 goes into 27. 19. Can you factor 19? No, it's prime, right? Okay, so if there are no greatest common factors, there's no pairs, then you just leave it. And then in that case, there's nothing you're going to be able to reduce. That would be your answer. Okay?